Hey everyone! We are absolutely surrounded by data these days. It's everywhere. From sports stats to sales reports, it can feel like you're just drowning in numbers. But what if I told you there's a way to cut through all that noise and find the one story that actually matters? Well, that's exactly what we're going to do today. We're going to build that toolkit.
Okay, let's just dive right in. Take a look at this. It's a spreadsheet with stats for 240 NBA players. We're talking age, points per game, free throw percentage. It is a total sea of numbers. Now, how in the world would you even begin to describe the typical or average player here? It feels impossible, right? It's just way too much to process all at once.
And that right there is the big question. That's the challenge. We need a way to boil all of this complexity down into something simple, something we can actually understand. How do we find that one number, or maybe a few key numbers, that can tell us a clear story about the entire group?
And look, this problem isn't just for sports analysts. Think about geoscientists trying to summarize river flow, or businesses looking at their sales figures, or even doctors analyzing patient data. Everyone faces this exact same challenge. But the good news is there's a proven method to tackle it, and we're about to walk through it step by step.
So, first things first, we need to find the center of our data. Now, this is what most of us think of when we hear the word average. But it turns out there are actually 3 different ways to think about the center, and each one has its own special superpower. So let's meet our 3 heroes: the mean, the median, and the mode.
All right, the mean. This is the one you almost definitely learned back in school. It's the classic average. You just add up every single value, say every player's points per game, and then you divide by the total number of players. It's simple, it's straightforward, and it uses every single piece of data you've got.
Next up is the median, which gives us a totally different perspective. Imagine you line up all 240 of those NBA players, from the one who scores the least to the one who scores the most. The median is simply the player standing smack dab in the middle of that line. Half the players score less, half the players score more. It's all about the position, not the actual numbers themselves.
And our third tool is the mode. This one's all about popularity. It's just the value that shows up more often than any other. So if more players are 25 years old than any other age, then 25 is the mode for age. This is super useful for finding the most common choice, or when you're dealing with categories instead of numbers, like the most popular type of car.
Okay, so now you've got 3 different tools to find the average. But which one is the right one for the job? Well, the answer really depends on the shape of your data. And to see exactly why, let's introduce a little bit of chaos, something we call an outlier. That's an extreme value that's way different from everything else.
Let's look at this pet example. We have a class of 20 students. The mean number of pets they own is 0.85, but the median is 0, which tells us that at least half the class has no pets at all. Now watch this. One student suddenly brings in 18 goldfish. Bam! The mean shoots up to 1.8 pets. That sounds like everyone has almost 2 pets, which is totally misleading. But the median? It doesn't budge. It stays at 0. Why? Because the mean gets pulled way up by the value of that huge number, 18. The median only cares about the middle person in line, and that person still has 0 pets. It just ignores the outlier, giving us a much more honest picture of the class.
All right, so knowing the center is a fantastic start, but it's really only half the story. We also need to know if all the data points are clustered tightly together around that center, or if they're spread out all over the place. And this measure of spread has a name. It's called dispersion.
And this slide shows you exactly why spread is so critical. Just look at these 2 sets of test scores. In both cases, the mean is exactly 50. But are these 2 groups the same? No way. Dataset A shows really consistent performance. Everyone's right around 50. Dataset B is all over the map. The mean, all by itself, completely misses this massive part of the story.
So the tool we use to measure this spread is called the standard deviation. The easiest way to think about it is as the give or take number. A small standard deviation means most of your data is huddled up really close to the mean. A big standard deviation means your data is scattered far and wide.
So what does a standard deviation of, say, 5 points actually tell you? Well, in a typical bell curve distribution, about 68%, or roughly 2/3, of all your data will fall within one standard deviation of the mean. So if the mean test score is a 55 with a standard deviation of 5, you know that most of your students scored somewhere between 50 and 60. It gives you a really clear range for where the majority of your data lives.
Okay, so we've talked about basketball and test scores. Now let's see how these concepts aren't just for school or sports. Let's put them to the test in a truly high-stakes application, where understanding these basic stats can literally be a matter of life and death.
And I'm not just being dramatic. We're about to see how geoscientists use these exact same simple tools, the ones we just learned, to predict when a tsunami is going to arrive.
So here's the scenario. A huge earthquake happens off the coast of Alaska. Scientists need to figure out exactly when the tsunami it creates will hit Hawaii. Now, a tsunami's speed is directly related to the depth of the ocean. So what do? They take 20 different ocean depth measurements along the tsunami's path, and the very first, most critical calculation they make, they find the mean, the simple average of all those depths.
And by using that one number, that mean ocean depth, they can calculate the tsunami speed, and from that, its travel time. The result? 5.10 hours. Think about that. An entire island's evacuation plan, thousands of lives, all depend on getting that one simple calculation, the mean, correct. It's an incredibly powerful example of how a basic statistic can save lives.
So let's wrap this up and recap the powerful new tools you now have in your statistical toolkit. We've talked about finding the center and measuring the spread. Now let's make sure we know exactly which tool to pull out for which job.
Here's the key takeaway. Nice and simple. Use the mean when your data doesn't have any crazy outliers. If you do have those extreme values, like our student with 18 goldfish, the median is your best friend. It'll give you a more honest number. Use the mode when you need to find the most popular option. And remember, always pair the mean with the standard deviation so you can understand both the center and the spread. And you know what the best part is? You don't have to do any of this by hand. Remember that massive NBA spreadsheet from the beginning? In Excel or Google Sheets, you can find all these values in an instant with these simple functions. It's literally as easy as typing equals average and highlighting your numbers. You can analyze hundreds, even thousands of data points in just a couple of seconds.
So from weather patterns and housing prices to your own monthly budget, data is absolutely everywhere. But now you have the fundamental toolkit to go beyond just looking at numbers. Now you can start to understand the stories that they're trying to tell. So the real question is, what story will you find in the data that surrounds you every single day?